All right, in the standard, I can draw diagrams as well as write one variable equations to solve problems, including problems with percentages. So in each of one of these, we'll have some kind of diagram we can draw to solve this. So first one, look, what we're doing here says draw a tape diagram for the situation and set up the proportion. You do not need to solve, and so we'll post this. So the attendance for the training increased 18% in the afternoon compared to the morning session. If there were 188 people in attendance in the afternoon, how many were in the morning session? So some key things I see here is it increased this percentage. I'm going to start off with my tape diagram. I'm going to label it 100% right away. It increased, so no matter what I'm trying to find, I'm still looking that I went up to 118%. I guess the only thing that would be doubtful if you're finding out how many people were in that 18%, but here we do know that we're going to increase that. Okay, so it increased in the afternoon from the morning. So there were 188 in the afternoon, so that was the bigger amount. That was when we had more people. In the morning, there was less people. So even knowing the order can help because we have 0 on each of these ends. Or you can also look at what it associates with. We know that the 100% associates with morning and the other one afternoon. So our proportion is 100 over x equals 118 over 188. This is our proportion, and that's all we're asked to do for this problem. So let's use some of those to solve some other ones. You bought a 1-year-old used car for $20,443.78. The car was decreased by 9.3% each year. How much was the car when it was new? So again, let's use a tape diagram, 100%. And then it went down. So it went down here. If I subtract that from 100, I'm at 90.7%. Okay, now this is the used car, so this is a depreciated value. So that's going to go right here, just a long number here. And we want to know at the full value, at the 100% what it was. So here's our proportion. We can solve this, so we're going to multiply to get rid of those denominators. So I have 90.7x equals this, really it would be 2,044,378. And then I'm going to divide that by the 90.7. So then I get 22,540, which seems to make sense. This was the original price, so it's higher. And we can't just take 9.3% of that other number and add it on. It's a little bit different value because taking 9.3% of this number versus this number is going to be different amounts. So use the tape diagram. Proportion comes really easily, and it does not seem like a difficult problem. All right, let's look at a couple others that we can use this. So in a triangle with two sides of equal length, the third side measures 15 inches less than the sum of the two equal sides. The perimeter is 53 inches. Find the lengths of the three sides. Okay, so this is talking about perimeter and size and stuff of a triangle. I really need a picture of a triangle. Scale does not matter for it. We're looking more in perspective. Now it says that two sides are equal length. So if this is x, so is this. And then the third side measures 15 less, so I'm going to subtract 15. And I'm going to do that from the sum of the two other sides. So I'm adding x plus x. I'm going to write it as 2x then. Okay, so that's all the sides. It says the perimeter is 53 inches. So to find the perimeter, we're going to add up all the sides. So we're taking x plus the x plus the 2x minus 15, and this is going to be 53. Sometimes I like to use that visual and just look at 2. I have an x plus another 2 x's. I'm at 4x, and then I have that minus 15. So that visual can really help. We'll add the 15 to both sides. and we'll divide by 4. And so x is 17. So that means that this side is 17 inches, this side is 17 inches, and then here we have 2 times 17 minus 15. So 2 times 17 minus 15 gives us 19. And we could always double check. We could add up those sides. They should give us 53. So use that visual to help you out, to organize your information. All right, the next one. So composite scores for the ACT fell from 20.0 in 2001 to 20.8 in 2002. What percent decrease? Ooh, percent decrease was the drop. Talking about percentages, I'm going to use a tape diagram. Starting at 100%, and it went down. We don't really know what it went down to. It started at that 21.0, and it dropped just a bit. So we're going to find out x, but actually x will not be our answer because we want to know how much we're subtracting from 100. So we'll do the x over 20.8 equals 100 over 21. So when I multiply here to get rid of those denominators, and then I'm going to have to divide here. And my x is 99.048. Okay, so I'm looking at the difference between 100 and that. So I'm going to take 100 minus this answer. And I get 0.952. Okay, this is the percent decrease. So this is the percent decrease. It's not too much, but also it really the scores didn't drop too much. They just dropped by 0.2. So there shouldn't be that drastic of a drop in it. And so that's why we see such a small percentage in drop. So we really do want to know what that x represents. And the x didn't represent the answer in this case. So we did have to do one more step. Let's look at one final question here in this category. The cost of a traditional Thanksgiving dinner in 2005 was $36.78. This is an increase of 37.5% over the cost of it in 1987. What's the average cost in 1987? Again, I think we can use a tape diagram for this. So original price, 100% here, and it increased. So we're at 137.5 degrees, or percent. Okay, so when in 2005 it was this $36.78. Okay, we want to know back in 1987. That was a smaller amount. We don't know this one, but we know this next one. Thanksgiving is going to be one of my favorite holidays to spend with family. We have a proportion here. Okay, and again, those tape diagrams are kind of nice because they just show like the size of things increasing or decreasing, and if things are higher or lower than each other. So when I multiply to get rid of my denominator, I'll have 3678 equals 137.5x. So then when I divide, my x, I get 26.75 when I round. This is the dollar amount. Okay, so nowadays it's probably increased even more, especially it seemed like during COVID, inflation has increased a lot, so I'm sure it's a lot more expensive. So using those diagrams can give us a visual representation of what's going on, and we all usually have a lot of visual tendencies, and so that's what really can help us to understand